Hi everyone, my name's Jim Webber, I'm Chief Scientist at Neo4j, and today I'm going to talk a little bit about graph operations on non-graph databases. And something really interesting's happened over the last year or so. The Neo4j folks, we've been into graphs like forever, and we've been plugging away, preaching and talking about graphs to anyone that will listen for so long. And actually over the last year or so, it seems that graphs have started to hit mainstream in the world of databases. And a lot of databases that have traditionally supported other data models are now trying to add on graph support into their offerings. I think this is really interesting. I think it's going to impact those of us that work with database systems, which is a lot of the developer community in the future. And it's worth exploring what the trade-offs are going with some of this new non-native graph tech versus some of the established native graph tech. So let's take a think about a document database. So there are document databases out there now that offer a kind of veneer of graph. In the document world, the underlying fundamental data structure is a tree, because a document database is fundamentally an advanced filing cabinet. Documents go in, documents get indexed, documents come out. Now, in order to reify a graph out of those documents, what I'll need to do, or what I used to need to do, was have some kind of metadata, some link data in there that I could, by convention, assume was a link between documents, and then I could effectively resolve that indexed link in my B-tree index or similar, and be able to then effectively hop at cost log n to another document and rinse and repeat. And I think sensibly, some of the document store engineers have decided that that is a desirable thing. Being able to traverse between documents is clearly a powerful idiom. Those of us that live in graph world understand that traversing is an incredibly powerful affordance. And so what they've done is they've taken that kind of rather clumsy user level convention, and they've tried to codify it. They've provided some kind of graph operator as kind of an addition to their existing non-graph query language. And now that graph operator provides some syntactic sugar over some hard work that the users used to have to do. So the graph operator kind of slightly automates that for you. Under the covers, it's still the same algorithmic cost. It's still B-tree style index, but the graph operator takes away some of the tedium of working with graphs in a non-graph way. So now I've got this graph operator, I can start to use some graph features in my non-graph database. Sounds great, until you scratch a little bit, and then you find that actually we're not terribly well served by this graph operator and its underlying implementation. Remember that the underlying implementation is native for documents, so it's optimized for that kind of store, index, retrieve pattern. And at log n cost for any reasonably sized database, that's a relatively slow thing if you're going to chain several of those operations together, as you do when you're traversing through a graph. It becomes m log n, in fact. Worse, the graph operator that we see becoming popular in such systems is rather poor in terms of its vocabulary. It covers quite a narrow view of what you can actually do with graphs. Under the covers, I think the engineering teams that have provided these have tried to do the right thing. They've tried to make sure that graphs aren't terribly slow on the non-native engine. And so they've done some level of denormalization and some other retrospective, clever indexing and so on. Even so, though, they're going against the grain of the native model, the native document model. And what we see empirically is that you end up hitting the limits of this denormalization at relatively modest depths, depth 3 or so in a search, at which point your query performance simply falls off a cliff edge. The way that end-user developers have to deal with this is they end up flattening their graph so that they don't fall off these cliff edges. But then they're kind of taking away the high-fidelity model of the graph and providing this kind of like pixelized view of a graph because of the arbitrary mechanical limits. Under the covers, of course, the engine is still a document management engine. The key core, if you like, database management system knows nothing about these links, knows nothing about graphs. It's written to provide management for documents, which means that if, as a user, I disobey or accidentally contravene some of these expected conventions upon which graph functionality is predicated, I can actually ruin my graph. I can leave dangling pointers, all kinds of bad things can happen. And that means that, quite conceivably, under normal use, I can corrupt my graph. I can damage the graph structure, and then based on small pieces of graph damage, I will make decisions about the graph which will lead that damaged structure to spread, effectively the contagion region will spread around the graph. So under normal operational use, I can quite conceivably corrupt this. That seems like a rather poorer affordance given the importance of graphs as we believe, and indeed as those vendors believe, because they're adding graph support to their systems. I think ultimately this boils down to a level of experience. We in Neo4j have been deeply concerned about graphs and building technology that's native for graph workloads for so long. Many of the people who have come from other database schools have had similar mastery, but in other models. So where Neo4j has nigh on 2 decades of just thinking about graphs, other schools have similar periods of time of thinking about a completely different model and relatively shallow experience in graphs. So they're going to be bumping into some of these obstacles and trying to figure out how not to go against the grain of their native model. In Neo4j, we provide a bunch of affordances to graph developers, things like visualization, things like a really pleasant, expansive and rich query language, whereas on the other side of the fence, none of this kind of thing exists. Even things that we take for granted in Neo4j, and indeed in the property graph model, being able to put properties on relationships, are hard to do, in fact, when your data model is reifying links in an index to resolve another document. It's quite inconvenient, impractical, if not impossible, to put data on those relationships. And of course, data on relationships is just as important as the data in the nodes itself. In terms of the fundamental mechanics, though, I think that graphs require quite strong consideration with respect to consistency model. Neo4j is ACID transactional. We have to keep the graph consistent so that we don't get this corruption that then spreads through the graph. If you have a system that's designed for some other data model, which is more permissive, where perhaps you don't need ACID transactions, where perhaps something like eventual consistency is good enough for you, that's not going to play out well in the world of graphs where you need stronger forms of consistency. Neo4j supports causal consistency even in multi-data center setups, precisely to keep the graph structure intact. In terms of just the day-to-day operations of these things, using the graph structure, if you're having to pay order m log n for a traversal, whereas Neo4j costs you order n, you can see that doing your traversals in Neo4j is going to be far cheaper. Neo4j is also optimized for graph traversals right down in the weeds, in the bits and bytes level. We have things like compact pointer representations, we have index-free adjacency and so on, and indeed our store format right the way down to disk is optimized for graph storage. In fact, we go as far as to separate in our data structure, to separate data from structure, and we emphasize massively the ability to traverse that structure in incredibly high performance. On the flip side, if what you've got is a B tree, you don't have that affordance available to you. And ultimately, and this is more, I think, emotional than scientific, but the graph community has rallied around graph technology. There is a rich set of experience of practitioners, of third-party tools, of third-party libraries, of applications and systems being delivered daily on graph-native platforms like Neo4j. Whereas if you are trying to extend your existing document database to support these kind of things, you have very little of that available to you. So ultimately, I think, I'm glad that graphs are finally being taken seriously as, get a seat at the big table by these non-graph platforms. But as a developer, as an architect, as an engineer, as a scientist, I think that we should take a step back, look across the technology that's available to us, and determine whether good enough graph tech is good enough, or whether actually we really need proper native graph technology to do the kinds of important graph workloads that are coming down the pipe for us. So thanks for your time today. It's been great to be able to chat with this video camera, and see you in the community soon.